I'll start section 2 by showing you what compound interest is about. So, like in the last section, if we deposit $100 at 10% simple interest, and we wanted to figure out how much we would have in 20 years, the simple interest formula, A equals P plus PRT, $300 is what that $100 would grow to in 20 years. Now the idea of compound interest is something like this. If we take the $100 and compound it annually, that means we deposit $100 today and look at it at the end of 1 year. That comes from the word annually. Here's what we would have at the end of 1 year using the simple interest formula. Now this is where it gets its name compounded though. For the second year, we're still going to use the simple interest formula, only the beginning sum of money is going to be the $110. So it's like we withdrew our $110 and then stuck it right back in the bank. And so figuring simple interest on $110 for 1 year, this is what we would have at the end of the second year. We could do the same thing for the third year, beginning with $121, figuring up how much it would be for 1 year. This is what we would have. Now, rather than me continuing all of these individually with you, I've already done this and put it into a table for you to see. This is the part that we've already done, the first 3 years. But look, this is what would happen if we continued doing that calculation for 20 years. As you can see, it's more than double the amount of money that we had at simple interest. And you can see from the calculations that we did that basically we're earning interest on our interest. Now here's the formula for compound interest that is printed on your formula sheet. And the quantities, P represents the sum of money in the beginning. The R is the interest rate, just like in the simple interest. The T is the time, just like in the simple interest. It has to be in years. And then the M, we haven't seen that in the simple interest problem. The M is called the method of compounding. Now that comes from the terminology in the problem. Here are the ones that you'll be encountering in our class. Annually is something that's done 1 time a year, and that's the value that we would use for M in the formula. Semi-annually means twice a year. We'd use a 2 in the formula. Quarterly, one of the most common in the business world, means 4 times a year. Monthly, 12 times a year, and daily, 365 times a year. So these are the values that you would use for M, and it'd be tied to the term in the problem. And so this quantity, R divided by M, is sometimes replaced by the letter I. The T times M is sometimes replaced by the letter N to give a different looking formula. Now this is not the formula on the formula sheet. The one at the top is the formula on the formula sheet. If you use the help button or example button on some of the homework problems, you'll see the bottom formula. Now back to the problem that we did just a moment ago using the magic chart that I produced. One formula could have produced the entire calculation. Here's the formula. P is $100. R is 10%. M is 1 for the word annually. And T is the 20. Type this into the calculator. Appropriate use of parentheses. You might take a minute to pause and try that on your calculator. Now I want to show you the different methods of compounding and their effect on the amount of money that we have. So in this situation, we've got $1,000 that we deposited at 5%, compounded annually for 10 years. Here's the formula with the numbers substituted appropriately. There's the sum of money. Now, what if that same one was compounded quarterly instead of annually? Well, the only thing that would change in the formula is those ones would become fours. Typing that into the calculator, this is the sum of money. Notice that's about $15 more. Here's the same thing, but notice the only change is the one word, monthly. So the calculation would mean 12 for M. Here's the sum of money. And if we compounded it daily, we just use the 365 for M. Here's the sum of money. Notice that all things being equal, the more often it's compounded, the more money we have. That usually brings up the question, so how often can it be compounded? Well, the term used for this is continuous compounding. That means more often than every second. There is a new formula for continuous compounding, and it involves something that we learned in Chapter 2, the exponential function with the natural base e. Here is a new formula, it's on the formula sheet, for continuous compounding. If we wanted to know, same quantities as before, how much we would have if this was compounded continuously, we have to completely change our formula and use the continuous compounding interest formula. Substituting the numbers in, doing the calculation on our calculator, notice that we get a whopping 6 cents more than if it was compounded daily. But again, that is the most that it could be on any sort of compounding. So that's the idea. Let me show you some examples using calculations. You can try typing these on your calculator and pause and look it over if you need to. I don't have all of the calculator steps on every one of these. And so here's the formula off the formula sheet. P is 2450, R is 0.082, T is 3, and M comes from the word quarterly, meaning 4. Here's all the numbers substituted in the proper places, and here's what it looks like on the calculator. So give it a try, see if you can come up with that, typing it on your calculator. The formula in yellow is on your formula sheet. Here's another one. Notice it says compounded continuously. We have to find the formula for continuous compounding. Then plug things in. Type it properly into the calculator. Now I've shown you two different ways of typing this. One literally with the time sign, and then the other one with parentheses meaning times. So here's another calculation. We want to find the value of P. And so using the compound interest formula, putting everything in its right place, here's what we want to do. We want to take this computation and type it into our calculator. Now, to make this better, we do not want to round off this answer. Don't call it 1.9. Don't call it 1.93. Don't call it 1.934. We do not want to round it off. The best way of doing this is to store this number into a variable. So if you push the STO key, it'll say ANS and then arrow, and then give your number a name. I've used the name K for this number. And so then to divide 9,000 by that number, I just need to do 9,000 divided by K. Now, you might practice on that. Again, pause and rewind if you need to, but look at how to store numbers instead of retyping them. Please don't be rounding off. You'll be missing problems eventually. And so here's another one. Again, same sort of question. Find P at continuous compound interest. Plugging everything in, we do this calculation, get a number, store that, and then divide 6,300 by that number. We can then round off to do decimal places, dollars and cents. Now comes the tricky one, solving for the T. We take our formula, we put everything in the right spot. We're going to begin by dividing out the 71,153. We're going to now need to find this number and this number. We take out our calculator, type each one of those, and give it a letter. I've taken the 88,000 divided by 71,153 and called it J. I took the other calculation and called it K. Now I have J equals K with an exponent of T times 12. We change this using the magic formula. And so here's log J base K, ln J divided by ln K. We need to divide that by 12, and that's the number we're looking for, rounded off appropriately. This can be quite a tricky process. And so let me show you what we could do to solve for the variable P and create us a new formula. If we take both sides and divide by the 1 plus r over m to the Tm, this is what we get. We can make this a little nicer looking by moving the 1 plus rm to the Tm up to the top and changing the sign of the exponent. That would look like this. Now, the proper calculator form of this looks like this. Now I'm going to take out my calculator and create me a program that does this, like we did in the last section. I'll go through the steps to create the program. We start with the program button, go to new, give it a name. I will call this, starting with COMP, so I can remember it does compound interest, and then tell it which variable I'm solving for. So the proper name might be something like COMPP. Press enter, and we start with program IO number 2, list our variables. You can see we've got an A, R, M, and T in our formula. Look in the yellow box. And so we'll list those. Now, it really doesn't matter what order you list those in. Press enter, and then we want to do the calculation. Now, I have put it for you right there in the yellow box. Just make sure you type it with all of the parentheses, exponents, and negatives in the right spot. And so here's what it would look like. Press enter, and the final step, program IO number 3, second A and S. There are the 3 steps of the program. All of these programs, you should be able to do the same 3 steps, different variables, different formulas. Second, quit. We're back to the home screen. Now, I'm not going to do this, but you can go back to in the slides to some of the problems that we did and test out your program. Make sure it works now, so that you can trust it on tests and homework. Now, we're going to take the compound interest formula and solve for the T. I'll go through this a little quicker. I don't think you should ever have to do this by your little self. However, these are the steps. And there's our formula. Now, the calculator version of this would look like this.